Okay, so we'll continue and complete the lesson. I think I did up to the polarization the last class, up to page number 22. Am I right? Question 17 was done, right? Okay, so to continue and complete the tooth today with the shapes of molecules and ions. It's a very important section because generally often students tend to memorize shapes and structures. I'm going to explain to you a method where you can derive the shape or the structure of any molecule without memorizing it. There are a few rules to follow. In fact, there are about 6 rules to follow. Follow those 6 rules properly, you can predict the shape and the structure with ease, right? When you say the shape of a molecule, first of all, I'm going to first explain to you how to draw the structure, and then second part of the lesson will focus on the shape. So first we'll focus on the structure, and then we'll focus on the shape of the molecule. Now the structure of a molecule is drawn in terms of a Lewis structure. Now what is a Lewis structure? A Lewis structure is a representation of a covalent bond in a covalent molecule, where a single bond is shown as a single line, a double bond a double line, a triple bond triple lines, right? For example, chlorine chlorine. This is the Lewis structure of Cl2. Carbon dioxide. Lewis structure of simple molecules we already know, right? Simple molecule Lewis structures we already know. Nitrogen, triple bond. So the Lewis structure, a single bond is shown as a single line, double bond, double line, triple bond, triple line. So this is the Lewis structures of simple molecules. I'm going to explain to you how to draw Lewis structures of complex polyatomic molecule or ion. Now when it comes to complex structures, there are a few rules to follow. When you do for the first time, you have to concentrate, and then when you get used to it, you can with ease you can derive the structures and the shapes without much effort, because that is what is expected from you all, not memorizing the shape or the structure. Even myself, if you ask me what's the shape or the structure of phosphate, honestly I don't know. But I can derive the shape and the structure within maybe 20 or 30 seconds. But I will not do any mistakes in that. So that's not how we got trained by our professors, because they don't encourage memorizing. Unlike nowadays, sometimes you will not learn this method in school, because the reason I'm telling you in advance, because teachers, some of them don't like to teach, some of them don't know these techniques. The reason is they think it's a lot of work for the teachers. So what they do is, in short, they take a A4 sheet and they photocopy all the shapes and structures. So you have in one column the structure, in the other column the shape and the bond angle. So you have 3-4 sheets of photocopies with all the structures. So this is not a burden, right? Imagine you have about 20-30 structures to memorize. The shape and the bond angles and the structures is going to be very difficult, right? So in this situation, what I'm going to do is, I'm going to explain to you just simple 6 rules, right? These 6 rules will help you to derive the shape, first of all the structure of any molecule, right? It's like driving for the first time. Driving for the first time, you have to concentrate, right? You have to, if you're driving a manual vehicle, you have to concentrate on the clutch balance, and you change the gear, you press the clutch and change the gear, and you have to concentrate a lot. But after about 1 week of driving, you will just, changing the gears, and you will be just doing all those without your knowledge, right? So that's called the subconscious mind. But this is also like that. For the first time, you have to concentrate the steps. And then when you practice, within few seconds, you can draw the structure of a complex molecule. Now the first rule is to draw the skeleton structure, not skeletal, skeleton structure. Now I'm going to start with the complex one first, sulfide. Why not the simpler one first? Why the complex one? Because complex one is going to cover all the rules. So if you can do the complex one, you'll be able to handle the simple one, right? Now look, the first rule is to draw the skeleton, not skeletal. Skeletal is different. We'll be discussing about skeletal structures later on the organic chemistry. Skeleton structure. What is skeleton structure? You connect the central atom to the terminal atoms by single covalent bond. Now what is central atom? Central atom is the one which has the least electronegativity. The least electronegative atom is referred to as the central atom. Now we discussed in the previous lesson how the electronegativity values will change down the group and across the period. Down the group, the values will decrease. Across the period, it increases. So if we take sulfur and oxygen, we know sulfur is below oxygen, so sulfur is less electronegative compared to the oxygen. So sulfur is the least electronegative element here. So select the least electronegative one as a central atom and connect the other atoms, which are referred to as the terminal atoms, to the central atom by single bond. Just single bond. Because that's the minimum number of bond which atom can have in a molecule. I mean, it should have at least one bond minimum. So we combine them with a minimum bond. There's one exception to this rule, the hydrogen. Now hydrogen can never be the central atom, because the condition for a central atom is that the central atom should be able to bond with many other atoms, right? So the hydrogen, we know it can only form one bond, so therefore hydrogen can never be the central atom. Hydrogen is always occupy the terminal position. Hydrogen can never be the central atom, right? Okay, the next, after drawing the skeleton structure, this is the first rule. So I just put for this number 1 to show it's the first rule. The second rule, you have to establish a total number of valency electrons. What is valence electrons? The number of electrons in the outermost shell. That's simply the group number. Sulfur has 6 electrons. Oxygen got 6 times 3, 18 electrons. 18 plus 6 is 24. For each negative charge, you add an electron. For each positive charge, you subtract electron. Now this sulfite has a 2 minus charge. Therefore, I need to add 2 electrons to this. Right? So it will be 26 electrons in total in the valency outermost shell. Second rule, you establish the total number of valency electrons as the group number of each element, and then for each positive charge you subtract electron. For each negative charge you add an electron. Because it's 2 minus, I added 2 electrons. Rule 2 is correct, clear to everyone? Right, the third rule. Now see, we know a chemical bond is a shared electron pair, a covalent bond. Because we are studying about the structures, when I say shapes or structures, I am referring to only covalent molecules. Right, only covalent molecules. Because ionic compounds, they exist as giant crystal lattice structures. Ionic compounds are not simple covalent molecules, they are not simple molecules. The shape and the structure of ionic compounds, giant lattice. Each cation has many anions, each anion has many cations. When I say shapes or the structure, I am referring to covalent molecules only. Right? Okay. So there are 3 covalent bonds, which means I have shown 6 electrons in total here. I repeat the second rule again. It's a very simple rule. You establish the total number of valency electrons. What is valence electrons? The number of electrons in the outermost shell, which is the group number. Sulfur is in group 6, oxygen is in group 6, so there are 3 oxygens, so there are 18 electrons for oxygen. 18 plus 6, right, is 24, and for each negative charge you add an electron. You can see the charge is 2 minus, that means I need to add 2 electrons. For each positive charge, you need to subtract an electron. This 2 plus, you subtract 2 electrons. Plus 1, subtract 1 electron. That's all, 26 electrons. Now, electrons out of 26, I have shown each bond is how many? 2. So, 2, 4, 6. Out of 26 electrons, I have shown 6 electrons here. That means there is remaining 20 which I have to show in the structure, because in a structure we only show the valence electrons. What are valence electrons? Electrons in the outermost shell. So for each bond you subtract 2 electrons. Right? Now you have to follow these steps. Now believe me, for the first time you have to little put some concentration and effort. And then once you start practicing 4, 5, 6 molecules, you'll be drawing very complex, huge molecules without any effort, right? So we found 26 electrons. For each bond, I subtract 2 because each covalent bond is 2 electrons. So 2, 4, 6. Just 4 covalent bonds, subtract 8 electrons. 3 covalent bonds, we subtract 6 electrons. For each covalent bond, you subtract 2 electrons. Electrons are in pairs, so you convert this into pairs by dividing it by 2. So you get 10 pairs now. So what I'm going to do next is that, that's the 4th rule. I hope third rule is clear to everyone. Abdullah group, the rule 2 is clear. For each bond, how many electrons are there in one covalent bond? How many bonds I have shown here? How many electrons I have shown now in the bonds? A 3 times table, if you know, okay, fine. 6. So for each bond, subtract 2 electrons. So 6 electrons I subtracted. That means I got 20 electrons. So pairs wise, 10 pairs. Is it clear, Abdullah, now? Now the 10 electrons I have to distribute among the terminal atoms. You'll be surprised at the end, because it will be so easy when you practice. Rather than breaking your head and memorizing 20, 30 or 40 structures, just knowing these 6 rules, you can do wonders. Right? Towards the end, you'll be surprised what you can do. Now see, actually this is how the chemistry is, It's the most easiest subject. It's the teachers who make it difficult. Because they don't teach, they always, right? What they do is, most of the teachers, I mean not everyone, so-called untrained people who don't, if you cannot simplify the subject, because we never encourage to memorize anything for students. The moment you start memorizing, you're fooling yourself because you don't know what's going on. You're just muttering and murmuring certain things, that's all, you're just recalling. This is not what is expected in chemistry. The principles, if you know the principles, you can handle any situation. Even tomorrow, if a new molecule is invented, you will know the shape. You can derive the structure. You can say this molecule has to be this way. Even if the molecule is still unknown, you can still do it. It's a simple covalent molecule. That's the wonder of this. Person who memorizes shapes and structures, he will only know the 10 or 15 structures he has memorized. Right? Look here. The 4th rule is that, because I want to give you the value for this, because even if you should know the value of what you are studying. Because at the end you can achieve a lot. You can derive the shapes, the molecules and the ions. So it's a great achievement. Now see, 10 pairs. What you should do is this 10 pairs, you first distribute among the terminal atoms. What are terminal atoms? Sulfur is central for the terminal atoms. you first distribute the 10 pairs among the terminal atoms so that all the terminal atoms which receives its octet. What is octet? The stable outer shell, 8 electrons. So once the terminal atoms receives the octet, that's maximum number of electrons it can hold, if any pairs remaining, you can put to the central atom. If nothing remaining, don't worry, just leave it. I'm going to take 10 pairs, right? See how many pairs I can put around each oxygen. This is 1 pair, 2 pairs. Can I put more? Yes, because oxygen can hold up to 8 electrons. How do you know that? Because oxygen is period 2 element. Period 2 element can hold up to 8. Period 1, only 2 electrons. Period 3 can hold more than 8. Nitrogen can hold only 8 electrons. But the one below nitrogen, which is phosphorus, has 3 shells. 3s2, 3p6, 3d10. It can hold up to 18 electrons. We have done this before. Right? So, can I put another pair of electrons to oxygen? The answer is yes. Because oxygen can hold 8 electrons. How many I have shown here now? 1, 2, 3, 4, 5, 6. Why I counted 5, 6 is bond? Because even after forming bonds, it should be able to hold maximum 8 electrons. So I have shown 6 with the bonding electrons. So I can show another pair here. 7, 8. So likewise, oxygen I can put 3 electrons. 3 pairs of electrons for each oxygen. So out of 10 pairs, I have shown 9 pairs. 3 times 3 is 9. 1 pair is remaining. I said if anything remaining, that goes to the central atom. That pair can be shown as a different sign. You can show as a cross. Right? If the adjacent is dot, the central it should be cross. Clear? Right. That's the 4th rule. Any questions here? The 10 pairs you first put to the terminal atom so that it achieves the octet. If anything remains, that will go to the central atom. Nothing remains, don't worry about the central atom. Rule number 4 is clear? Right. Rule number 5. I will do the rule number 5 in the 4 itself. Okay. Eshan, now the 10 pairs you got, right? The 10 pairs, first you put to the terminal and anything remaining, put to the central. Terminal oxygen can hold 3 pairs each. Because oxygen is a period 2 element, it can hold 8 electrons. Second shell can hold 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So already there is 8. Right?